Hello everybody, and welcome to episode 2. This time, last episode we talked a lot about the basics of the game, but this time I'm just going to have a little bit of building fun and see if I can get this, get Jebediah up into space, up into the higher level of space so that we can collect as much science as possible and bring him back down. Also, we have some new instruments. We have the thermometer this time, so I'm going to drop one of those right there. And also, we now have a stack decoupler that we can use to make our landing a lot softer. Plus, we have this new liquid fuel tank, which we can pair with one of our liquid fuel engines, and this gives us an engine that is throttleable. So I'm going to go ahead and let's see here. With this, we've got a thrust to weight ratio of 4.86 and a little over 1200 delta V. So with that, now it didn't change the computation at all, so that means we've got something wrong with our sequencing over here. So I'm going to move this down to the bottom and then put these in the same stage, and that is going to be on the next stage up, and then the parachute's by itself, and everything's fixed here. So this solid fuel booster alone gives us 800 delta V for a total of 2000, which is enough to get into space probably, but not anywhere near enough to get into orbit. But let's see where this takes us to exactly. Now, I could put a transmitter on there that would allow us to transmit our data back to base when we collect it. The problem is that transmitters use a lot of battery power, and the only battery power we have so far is the electric charge that is in our capsule, which is 50 units. I'm not even sure what those units exactly are supposed to represent, but that is not very much when you're talking about transmitting science back. So I'm going to save all that electric power for the steering systems on our spacecraft, and I'm going to call this the Upgoer 2, since that is all that it is designed to do. And hopefully this will get us at least up to 90,000 feet, but to be honest, I'm not really sure. Now, right off the bat, we get a temperature scan at the launch pad, which I will keep. I'm going to right-click on this thing to make sure that we are in fact transferring all science, yes, to the Mark I command pod, which is exactly what I want. And press T to turn on our SAS system. Once again, check the staging, and go. Oh, right away we get a temperature scan, which we'll keep and move to our pod. Accelerating nicely, 150 meters per second. I noticed in the last video I said feet several times when I was talking about altitude. Of course I mean meters, because we are scientists and we use the metric system. Alright, first stage is done. Now our throttle is automatically set at 100%. We can change that with using Control and Shift, and we can jump to 0 with X and 100% with Z. Here's our G-force meter right here. Ooh, I'm going to get this on the prograde so that the spaceship will continue prograde. I love watching this as we rise above the cloud layers here. We are at 17,000 feet, and our apoapsis height is only 59,000 feet and falling, so we're not going to make it into space, but we did get into the upper atmosphere. We get a crew report, temperature, and mystery goo, and that is just fine, and it looks like we're going to come down in the water. Now, since we are done accelerating, I'm going to go ahead and drop off that bottom stage, which I could have put a parachute on, and we could have held on to it for a little while. And I'm going to accelerate to 4 times time warp. to speed this up a little bit. I'm going to go ahead and turn off the SAS and just float. We are up in space. We can get a look around. Oh, there's the moon. Something to inspire us for a mission in the not too distant future. Let's see here if I can... That could be Magellan, but I don't see the W constellation, which would point to it. Oh, and we're dropping back down. Lost sight of the stars. Gonna fall into the water here. Oh, so we're taking another temperature scan over Kerbal's water, and a crew report over Kerbal's water. When we get down to about 3,000 feet, I will pop the parachute. We're still... Oh, let's get that time warp up there to 4. Nope, 5,000, 4,000, 3,000. We're going 230 meters per second. And I'll let that parachute out. Bring the time warp back up. Parachute opens automatically at 1,000 feet, keeping the time warp up. We're dropping at a nice slow about 6 meters per second. I will bring the time warp down right before we hit the water because it's not good to impact things under time warp. Physics has problems under time warp. And splash down. We're going to need a little bit more science from the water, and we'll cover our vessel. That was a pretty successful mission, but I did intend to get into space that time, which we fell about 15,000 feet short of. Now that's 52 science, which we could go spend right now, but I don't really need to. I'm really set on actually getting into space. So I think the easiest solution to that is to come in with some radial decouplers. I'm going to go up to 4 times symmetry on there and add some more solid rocket boosters. Make sure that they are in a separate stage. So we're going to get the boosters to fire first, and then the radial decouplers will drop those off. The stage after that will fire the next booster. This will definitely get us, I'm going to call this the upgoer 2B. And launch. A lot of this game is just experimenting, and it just occurred to me that one of the things I could have done was put some aerodynamic fins right here. It might help us steer when we get up to the higher altitudes. Remember to turn on your SAS, and here goes. And you almost never want to turn on time warp while you're launching. It's very easy for time warp to create weird aerodynamic effects when you are accelerating, and makes launching very, very difficult. Almost always your ship will end up flipping over for some reason in the atmosphere. And stage 1 is complete. Drop it off. Fire stage 2. And just as I feared, we have no aerodynamics. So I'm going to go ahead and revert this flight to vehicle assembly. Now if I was playing on hardcore mode, that would not be allowed, and I would have had to complete the flight. But I am sure that Jebediah would have survived that flight. Just would have been a little bit time consuming. So here, if I put 4 of these, get 4 by symmetry on those, that'll move the center of aerodynamics down to the bottom of the spacecraft and make it easier for us to maintain our aerodynamic profile after we drop off the initial stage there. And turning on the SAS, doing a quick check of everything, and here we go. Attempt number 3, or 4 I guess, if we count our very first mission, which I knew wasn't going to get into space. And watching all of our Delta V, which is individually accounted for. Now, those numbers are updating in real time to account for the changing mass of the spacecraft. And we're at stage 2. Oops, looked like some of those collided with each other after dropping off. Look at that pillar of fire that we are launching. We're leaving behind us as we rush up into space. Now we're watching our apoapsis, which is the highest point in your orbit, climb pretty quickly, 45,000 feet, dropping up that stage. I'm not going to keep that. There was only about 2 science there. We would have benefited from that. Right now, see now, we're actually at 1,000 meters per second. We're starting to see some atmospheric heating effects. So I'm going to go ahead and coast because our apoapsis is already 123,000 feet. And what I want to do at this point is actually save my fuel and slow myself down before I come back into the atmosphere. In order to save electrical energy, which we have plenty of right now, 48.84, and this engine actually generates electric charge whenever we fire it, so probably won't run out of electric energy on this mission. We're only going to be out of the atmosphere for a little bit, but this is a great time to press M and look at our orbit. So this is what our orbit looks like. You can hover over the apoapsis and it tells you how long, 2 minutes and 3 seconds until we get there, and how high it is at 122,123 meters. Now, we are actually in space. You can tell that because the music's changed. And we're going to do the mystery goo observation, and a crew report, and a temperature scan, and another mystery goo observation. Why not? Take 2 of them. I'm going to turn that on to maintain the orientation of our spacecraft. In fact, I'm going to move it up like this, and then I'm going to zoom in a little bit. Right-click on there, and I'm going to tell it to aim the camera at the pod before I do an EVA, because this will allow me to get 8 more science in an EVA report, and I really want to get brave. I can let go and float away, and I grab back on, and then I let go, and I have floated too far away at this point to come back. So what I'm going to do is press R and engage my jetpack. Jetpack steering is not easy at all. And as you can see, I am kind of messing it up. I have to make sure that I get back in that spacecraft before I impact the atmosphere. I've got plenty of time for that though. Shift and Control are up and down, while let's see, W and S are forward and backward, and then A and D are left and right. There, I got close enough to board the spacecraft. It wants me to repeat that mystery goo experiment. Sometimes this automatic science sampler will ask you to needlessly repeat experiments. I'm going to set this the SAS for retrograde, and then I'm going to time warp. Now, time warp goes a lot faster in space, and it is somewhat dependent on your altitude, but you can time warp up to 100,000 if you are in a high enough orbit. Now, at 63,000 feet, we're actually in the atmosphere, and I'm going to go ahead and burn the rest of our fuel, making our re-entry a little bit lighter. And we are now at 53,000 feet, falling at 600 meters per second, and actually still accelerating because atmospheric resistance is still pretty low at this point. I'm going to go ahead and turn off the SAS because we should just fall in like that. Now, you got to be careful because we are actually coming into the atmosphere at a fairly... Now, see, my parachute's still red. Oh, there it goes. You kind of have to be careful because if you're coming in the atmosphere at a really steep angle, you can actually come in so fast that you don't have time to slow down to parachute-friendly speeds, which vary depending on the type of parachute that you use, but are usually around 300 meters per second. And I'm going to go ahead and time warp until we get down to the level of the ocean. Beautiful rendering on the water there. Looks like the Kerbal Space Center is not too terribly far away from where we're at. We can press M to get a nice view. No, it's right there, almost visible on the horizon. Yeah, so it should be right about there on the horizon. And speed that up, down to 30, 20, 10, and we've landed. Cover the vessel. Oh, you know what I should have done is an EVA to get some of that water science. Anyway, next mission. So we're now at 93 science. We'll go spend that real quick before we end this episode. Definitely going to get the next two, which leaves us with 58. And these are all cost 45. So batteries would be very useful. This would give us our first set of batteries. Over here we could get some fins which actually allow us to steer, as well as the mech jeb part, which gives us somewhat more of an autopilot. Reaction wheel, a more powerful reaction wheel so we can steer our vessel better. This would give her some larger fuel tanks and a Mark I crew cabin. And this would give us some new engines. I think I'm going to go for the batteries. And the Science Junior, of course, is a new science experiment. Alright folks, that's it. Thanks for watching, and I'll be back soon with episode 3.